Welcome to Hydrogen Torch. This is the homepage. On the left side, you can see the navigation bar, which allows you to import and list the datasets, create and list the experiments, predict on new data, and list the predictions. Now let's import our data to Hydrogen Torch. We can import the data from S3, from Kaggle, or by directly uploading the data. We will import the data from S3. We will be using image object detection dataset, where the goal is to identify the weed heads. After the data has been loaded, we need to adjust some settings. Every setting has a tooltip in the top right corner. First, we specify the dataset name. We then select default problem type for our data. In this case, it is object detection. Further settings depend on the selected problem type. Formats of the data are described in the documentation. For image object detection, we need to select train data frame, Parquet file containing information about objects in each image. We will see the data frame structure later. We then select data folder. It is folder containing the training images. If we have separate validation data frame, we would select it in the next step. Validation images should be located in the same folder as training images. Optionally, we can provide test data frame if we have test data and test data folder. For object detection, label consists of class labels and bounding boxes. Input data frame should have class ID column specifying the class, and 4 columns for bounding boxes: xmin, ymin, xmax, and ymax. We also need a column specifying the name of the image. When all settings are set correctly, we click on the Continue button. We should verify whether the dataset was loaded correctly by clicking on the dataset name. First quick check can be done by inspecting the sample train visualizations. Visualization differs for each problem type. If you see an error message in this tab, you will need to go back and edit the dataset. Commonly, an incorrect problem type was selected, or one of the settings, like data folder, image column, or label, was not set correctly. In object detection, we can see sample images with all the bounding boxes. In our case, we only have objects of a single class. Let's have a look at the sample train data. First column is the image ID column specifying the image. Class ID column contains the list of class labels for all objects in corresponding image. In our case, we detect a single type of object, weed head. Therefore, all class ID values are zeros. Columns xmin, ymin, xmax, and ymax contain lists of the same length as the class ID list for the same row, and represent the edges of the bounding boxes for corresponding objects. We also have an optional fault column, which will allow us to select which fault should be used as validation while creating the experiments, since we haven't provided separate validation data frame. We can inspect train data statistics and have a look at the dataset summary. We can create a new experiment from the dataset list page by clicking on the new experiment, selecting the dataset we want to model, and clicking the Create Experiment button. We can also create experiment by clicking the Create Experiment in the navigation bar and selecting the right dataset. On the top, you can see Experience Level selection box. Options vary from novice to master level. Each level exposes more settings than the previous one. We will discuss the grid search toggle later. After selecting the dataset, you need to specify the problem type. We have already specified the default problem type for our dataset, so we do not need to change it. One dataset with set default problem type can be also used for experiments of different problem types. This option allows us to override the default dataset problem type. Similarly to dataset settings, every setting has a tooltip in the top right corner. We can also change the experiment name. Dataset settings section depends on a selected problem type and allows you to override all the settings we set when importing the dataset. There are many other settings depending on the current problem type, but some of the common settings presented for all problem types are backbone. We can specify the backbone architecture. Faults. If you provided a fault column during the dataset import, you will be able to choose which fault should be used for validation. Loss function, the function that our model will be directly optimizing, and validation metric. Hydrogen Torch provides a good set of default settings, hand-selected by architectural grandmasters, so your baseline model should be generated using these settings. You can then improve baseline model by setting the different settings. We can also turn on the grid search toggle. This will allow us to start grid search of experiments with different settings combinations, like different backbones with different learning rates. Once we are happy with our settings, we can click on Run Experiment button. Once the experiment is started, we can click on the experiment name and see the experiment. Charts tab shows learning rate, train and validation batch losses, and validation metric. Summary tab shows brief information about our experiment, loss, validation metric, and data. Metrics tab shows all available metrics for the current problem type. In case of classification, it also shows the confusion matrix and allows user to see how different prediction thresholds affect the metrics. Train Data Insights tab shows samples of augmented train images. Validation Prediction Insights tab can help with model debugging. It presents different validation prediction samples together with ground truth. For object detection, we can see how different prediction thresholds affect the predictions. Changing between random, best, and worst validation samples can help us identify strong and weak points of our model. Logs tab contains the experiment logs. Config tab stores the information about all experiment settings. Once the experiment is finished, we can use the model to predict on the new data, download the logs, download the predictions containing validation predictions and optionally test predictions if test data was provided, download the Python scoring pipeline that can be used outside of Hydrogen Torch, or download the MLOps scoring pipeline that can be deployed to the H2O MLOps. We can use experiments to predict the new data by clicking the Predict Data in the navigation bar. We need to select the experiment, which contains our trained model, and then select the dataset we want to make predictions for. We can adjust dataset settings and change the metric settings. We then click Run Predictions button. Once our predictions are computed, we can inspect the predictions. We can see similar tabs we saw for the experiment. We can then download the predictions by clicking the Download Predictions button.